Here we go. So I didn't do a very good job of telling you kind of the context of this problem. This is from a real thing. The Tampa Bay Rays baseball team in 2010. I know it feels like a long time ago. It was. No ice. No ice. You come out with ice, it's going to be 7 pHs, one for each piece of ice. Now, recorded. Now, the context of this problem is at the Tampa Bay Rays home games in 2010, if the team scored 7 or more runs, then the fans there received a coupon to get free tacos. So that's where this comes from. That's a real thing. All right? Excellent. Thank you. So, what is the probability that a fan got a free taco and saw a Rays victory? So that's taco and, bless you, victory. Well, how many games did the Rays play at home? How many total games were played at home that season? 81. Very good. Okay, 81 games. And how many of those games did a fan get a free taco and see a Rays victory? So that's taco and win, which is 13. So if you wanted to get a decimal, you take out your cell phone, do 13 divided by 81, and you've got the answer. I don't expect you to. What was it? 0.5625? 13 divided. Yeah, I got 0.160.
Wait.
Yes, Jessica.
Wait, so 13 over 81 or 81 over 13?
13 over 81. Did you figure out what you did wrong?
No. How far into the decimal should we go?
Oh, usually I just go I would probably do this for this one. Right, round to the thousands place. Okay, number 2. What is the probability that a fan saw a Rays victory, so victory, or received a free taco at the game? So this is a new thing. Okay, so in chapter 14, before I went on my little sabbatical, all right, chapter 14, when we did or, all you did was add them together, right? That's all you did. Or, cool, add them. Now watch what happens on this one, all right? So what's the likelihood that a fan saw a victory? So that's the 81 games. They saw how many wins? 49 wins. How many times did they get tacos out of those 81 games?
13.
No, 15, right? Just taco, right? Whether they won or not is 15, right? But here's the thing, guys. Within these numbers, there are fans that are being counted twice, right? Some fans attended a game and saw both of these things happen. Okay, so you have to subtract the probability that they saw a victory and got a taco, which we just found. Remember that one? So you got to subtract out 13 out of 81. So I'll come back to this problem in a moment. Let me just show you the formula you're going to get on your formula sheet. It's right here. I mean, literally just have it circled already. Well done, Douglas. Yeah, previous Douglas is one step ahead. So what I'm saying here is the probability of A or B is the probability of event A happening plus event B happening, but subtracting out the probability of and them both happening at the same time. All right, so that was that piece. That's a new piece in this chapter, in chapter 15.
No ice.
No ice? Okay, we're good. We're good. All right, now I think, Jasmine, you said this was 64?
Well, no.
But now it's to subtract 13, right? So what's 64 minus 13?
I got this. 64.
51. Okay, so you go to your calculator. Not Adrian B's calculator, since that's clearly wrong. And do... it's user error. 0.630 if you're rounding. Again, Diego, I'm not that worried about the rounding. I think what I'm saying is on the AP exam, it'll be very clear which one's the answer. It's not going to be like 0.631, 0.630. No, it'll be far enough apart. You'll know. Any questions on number 2? So that's a new thing for chapter 15. Okay, I'm going to go to number 3. If we randomly select one of the Rays victories from 2010, what is the probability that a fan at that game received a free taco? This is called a conditional probability. All right, I can almost guarantee you'll have a question like this on the AP exam. All right, a conditional probability is telling you that something has happened. What are they telling us to assume has already happened when we've selected a fan? The Rays won. So watch how you write it. You do the probability, and I put this symbol here. All right, that vertical line means whatever I write after it is the given, the condition that has already happened. So you put given that the Rays won. Okay, this changes things about how we're going to deal with this problem. So we're telling you that the Rays won. Now, what's the likelihood that the fan received a free taco?
13.
Hold on, let me go over how to do it. So remember how so far I've only been doing 81 in the denominator? Because that's the total number of home games the Rays played in 2010. But now I don't care about 81 games, right? That's the total number. I care about how many games they won. How many games did they win? 49. So my new denominator here is the given. They're telling me only care about the Rays victories, so my new denominator has to change to be 49. So now, if you're only looking at the win column, all right, what's the likelihood the fan also got a taco? 13. So it's 13 over 49. Again, that's new in chapter 15. 0.27?
Well, 0.265.
27%?
I mean, nothing is ever what it seems.
Or if you round it up.
Ben, you remember the restroom?
Leave your cell phone. Take the phone. I'm going to pause here. Any questions on number 3? That's a conditional probability. You will see that on our test. Yeah.
I gotta do that.
Okay. Yes, I'm sorry, Nicole. Raise what? Raise wins? The number of Rays wins? So this, you're talking about just like what it means? Like at the baseball game, the Rays won the game? Is that what you said? It's a baseball team. I could have changed this to been the Astros. You're good. It's the Tampa Bay Rays. All right. They used to be the Devil Rays, but then they took out the Devil part. Now they're just the Rays. And someday they'll be no longer in Tampa. Anyway, let's do number 4. Let's do number 4. Are you okay? What's the probability? Oh, is Marco? Not even you? Wow, goodness. Adrian, I'm so sorry. What shirt are you wearing?
Not a fear.
Beverly Hills Polo Club. I'm not sure that's the school we attend right now. Anyway, number 4. Number 4. What is the probability that the Rays won the game? And this time I'm trying to like throw it at you in your face, given that free tacos were given away. All right, so I'm literally shouting at you, what is the condition? What is the condition that they got tacos? Very good. I think I heard you. Hold on. Let's just start by setting it up first. If you feel ready to write the fraction, please write the fraction. So now all I care about is looking at only those games where fans receive tacos. So how many times did the Rays fans get tacos? 15. So my new denominator is 15. And out of those 15, how many times did the Rays win? 13. That kind of makes sense, right? If you get tacos by the Rays scoring 7 or more runs, that's a lot of runs. Most likely, they're going to win the game as well. All right, so 13 over 15. 0.867. Go ahead, Jasmine. Okay. going to pause here because now it's going to get a little tougher. I'm going to ratchet up the difficulty a little bit here. Number 5. Okay? This word is back. Independent. Can anyone tell me, without using the words tacos or rays, just in general, right, what does it mean when I say two events are independent of each other?
They don't depend on each other.
Poorly.
When one happens, the other is in the
Yeah, the other one.
There we go. That's a little bit better, right? If one happens, Juan said he raised his hand. Go ahead, Juan.
That if one happens, like, that if one event happens, the chance of the other one happening is not possible.
No, that's different. You were so close. You're so close. And I appreciate you raising your hand. You're also sucking on a blow pop, so those kind of balance each other out for like being a good student. So, one, you're so close to the very end, right? If one happens, then the likelihood of the other happening should be unchanged. It should be the same. They don't affect each other. Okay? So that's what independence means. So there's actually a mathematical way to do this. I'm going to go to the notes here. There's a mathematical way that's not on the formula sheet that you need to know for how to do this. Where is it? Right here. Nope. There it is. You see this right here on the notes? All right. I'm going to show you how I always process it. All right. But there's two ways to do this depending on which event you look at first. I'll show you both since we're practicing. I'll show you both, but you only need to do one. Please, please, please. Only do one when you do this for me. Okay? All right, so here's how you do it. So I'll let Juan, since you were following directions, do you want to start with taco or victory? Taco, okay. So what's the likelihood that the fans received a taco or free tacos after the Rays scored 7 or more runs? So it was 81. How many times did they get tacos? What was it, Marco? 15, very good. All right, so what is 15 over 81? I'm not sure what those noises are.
0.185.
Very good. Okay, now this is the most important part. So if you're not listening, make sure you're paying attention right now. This is the most important part. Okay? I am going to look at the likelihood of the fans receiving tacos again. But this time, I'm going to tell you that they already saw the Rays win. Okay? So I'm going to give you the condition is that the Rays won. Okay? So how many games did the Rays win? 49. How many times out of those 49 did they get tacos? 13. Which I think we calculated it previously was 0.265. I'm going to pause here, and I want you to look at those two decimals. What do you notice about them? They're not the same. Okay? They're not the same. They're not close. They're not the same. No. Close would be like less than 1 percentage point. Okay? That's 8. Okay? So they're not the same. So this means we've just proven that these events, taco and win, are not independent. All right? And it kind of makes sense, right? Because if I tell you that the Rays won, they had to score more runs than the other team. All right? Which means they probably had a better chance of scoring closer to 7, right? Which means they had a better chance of getting tacos. So you're more likely to get tacos if the Rays won the game. What I just said is the statement I'm going to write later. All right? Yes, Adrian P.
Where does it say that after 7 points they get a taco?
It didn't. That's why I said I did a poor job of explaining this to you. So now I'm here telling you, right, in my video, you'll hear it.
Wait, are you sure?
I am still recording. It's awkward. Okay. Can I show you the other way? Because Juan chose taco, but what if Juan had said victory? Okay. Marvelous Marco. Okay. Out of 81 games, how many times did the Rays win? 49, wasn't it? 49. So what was 49 out of 81? Here comes Adrian yelling at me.
I did it wrong.
I beat him!
0.605.
Oh, you lose. Okay? Now, if I want to do this way, I want to look at the likelihood that the Rays won again, but I have a new condition. The condition is that fans received free tacos. So how many games did they receive tacos? 15. How many times did the Rays win? No. How many times did the Rays win? 13, which we just calculated was 0.867. And what do you notice about those decimals? They're not the same. All right, so this is the other math that could prove that these two events are not independent. So this is showing you that if I tell you the fans got free tacos, you know in your mind, now that Adrian cleared it up for us, that they scored 7 or more runs, then you're more likely to see a victory. Your odds of seeing a victory have improved. It does make sense. Gosh, it's the best. Questions? What do I mean by what? I love learning things. That's what I meant by that.
Oh, that's what you mean?
Yeah. Do you not?
No.
I think it's interesting.
Okay. Overrated. Okay. Questions on 5? Questions on 5? What am I doing in my life? Is that what you said? Staying? Okay. Gotta go to 6. I'm gonna go to 6. Do you guys remember the vocab term mutually exclusive from before I left?
Yes.
What does it mean?
Nice. Kenya was ready for that one. What did you learn when you were going over this at Beverly Hills Polo Club? It does mean that they're destroying. What does that mean?
Yeah, what is that?
Perfect. If one happens, the other can't. So if I tell you that the fans received tacos, then the Rays couldn't win. Or if I tell you the Rays won, then the fans couldn't receive tacos. Well, guys, we know that that's not true because
We proved it in question
13 times
They got tacos.
fans got tacos
They won.
and the Rays won.
I agree.
So what do we say? NA?
I'm going to write a sentence. That's what I encourage you to do.
Not applicable.
Something like that, right? Doesn't need to be word for word, but something to show that there are instances of these things happening at the same time. Yes, one. Is my hand okay? Oh, yeah, don't worry about it. I've been for the last week, I haven't done that, so I'm saving up.
He's just trying to get back to it.
Yeah, you got to work up to it,
Yeah.
It's like riding a bike. Oh, Henry! He rode his bike to school today?
I like how
Awesome.
he's the first thing you think about.
He's the first thing I think of?
Yeah, like when you thought of the riding the bike.
Yeah, because I was trying to bring it full circle to what I said at the beginning of class.
Yeah, it's like a good daughter.
It's like context clues.
It's a good father-son moment.
It was. I didn't do anything. He did it all.
But you being there, it's like that's all you need.
But we were all there without the training wheels. Yeah, because he rode his bike to school the 2 days before we quarantined with his training wheels. And I love that he didn't care. He's a kindergartner, and he didn't think anyone would make fun of him for having training wheels. And then we were going for a walk on Wednesday, and he was like, I think I want to try without the training wheels. I was like, all right, man, go for it. Boom. It's an amazing feeling. He has cuts and scrapes all over his body, but it's awesome.
I need the training wheel.
There you go.
You wanted to do without the wheels?
He did, because we were going to pressure him. We just hey, man, I think you're ready. He's like, no, I'm not ready. Whenever you're ready, are you ready? He's like, oh, yeah, I'm ready.
How did he ride his bike to school? Is it 2 seconds away from your house?
Yes, we live right down the road. So he probably gets there in 32 seconds, maybe less, 17 seconds. But it's less about that and more about he gets there's a fourth grader right next to him. Put your bike in the bike rack. Put your helmet there. That's cool. I know you guys are seniors now, so hey, nothing's cool for you guys. But when you're a 5-year-old, that's cool. He's 5. He's so young. 72 pounds. Okay, let's go to the next one. Yeah, he's a large child. He just went to the doctor on Monday to get tested. Can we flip it over? Flip it over. He's 4'2". 4'2". Yeah, my older brother says he's going to be a linebacker. So we'll see. We'll see. What? Speaking of football, let's read this one. Adrian, do you need to tell us something? Is everything okay? Okay, so you're guilty. Got it. Okay. Listen, I am a human before I'm a statistician, right? I have biases.
I don't know. You're kind of you're a statistician before humans. You put your human to the side.
Put it to the side like it's over there. Okay. Let's read this because I need you guys in 3 weeks. When you read a question like this on our test, you need to know that this is screaming at you to make a tree diagram. Exactly. I can tell you didn't watch any of the videos or read a textbook.
I was just testing.
You were just testing.
I thought you didn't have a video.
I did send an email.
I saw the email.
Thank you, Ken. Very.
I just didn't click the link.
So, when I read a question like this, and we're going to practice, Adrian, when you come back from Thanksgiving, we'll have a question like this on the review where I need you to know that it's asking for a tree diagram. So we're saying that 5%, so 5%, 0.05 of the NFL players right now are using steroids. So I'm just going to put using. I don't know if that's true, right? It's just a made-up story. Okay. So that means if this is true, how many are not using? Thank you for those of you that said the rest. 95%.
Oh,
Right? Because there's only two options here. You're either using the performance-enhancing drugs or you're not. There's no like wishy-washy here.
Did you do that on purpose?
Did I do what on purpose?
Nah, like the way
I did. I'm making a tree diagram, as Adrian B knows.
Oh, wait.
Now, it says in the problem that 3% of players who are not using are going to test positive. What in the world? So 3% who are not using are going to test positive. So that means how many are going to test negative?
What is negative?
0.92.
No, 0.97.
Why?
Because 97 plus 3 is 100.
Oh, that's true.
Okay, thank you.
So we're just looking at proportions here now.
Yep.
Wait, we're doing that. 97.
Dude, you're not
I'm looking at like step by step here. Here's the first part of the tree diagram. 95 and 5 is 100. The second piece, 97 and 3 is 100. Now watch this. It says 1% of players who are using them will test negative. So 1% are going to test negative. So that's 0.01. So how many are testing positive if you are actually using? 0.99. I'm very confused. Clearly, I have not done a great job of teaching this yet. No, it's called subtraction. That's the word you're looking for. I'm going to pause here. Yashika, you all good? All right, you're typing, and this doesn't require typing. So as I call you out on this video, I just want to make sure we're all good. Excellent. Yes, your inverse psychology is forever going to be linked to you. I can't wait for students 15 years from now to hear that. Okay. Is everybody good on the setup? Because the setup is the most important thing. If the setup's wrong, anything we do after this is worthless. Everybody good? Okay. Now, when you go across the tree diagram, so like when I look at a tree outside, I think, oh, when I go across the tree, I think multiplication. All right? When you go across the tree, you think multiplication. So when I look at squirrels going across the tree, I think multiplication. Exactly.
That's the way of life.
That's not.
How is it a tree? Yeah, I don't see it.
Sandy cheeks.
Oh, it's not really a tree. It's just called these branches. They call these branches.
Tree diagram. Where did the 99 come from?
From the
From you,
0.0.
one user.
From the problem.
No, then he would be the 0.01.
Positive? Right? Positive means they're using.
No, yeah.
No, positive doesn't tell me if they're using or not. It tells me the test is reporting that they're using it.
That's
Right? There are false positives and false negatives. Okay, so everyone, if you have your phone out and you want to do this, I'm going to go across the tree diagram, and I'm thinking multiplication. So 0.05 times 0.99 is 0.0495. So that's the first one. This one you probably can do without your phone.
Oh. Wait, so wait, where does the 99 come from?
Do I need to show it? Okay.
The 99?
It comes from this. It tells me that 1% of the players who are actually using PEDs will test negative. So 1% of the users are testing negative. So 99% of the users will test positive.
Oh, so I see.
Okay.
So it's 99% accurate.
No, it's just saying that 99 doesn't count.
Oh.
That's why.
I'm so close, Marco. Can you wait?
Wait, you heard that?
Yeah, you just went, restroom.
Okay, that's what I was like mumbling to myself.
You mumbled pretty loudly. Remember to raise your hand if you have a question on how I got any of these probabilities. Please raise your hand if you're confused by any of the numbers. Yes, Fatima. Yeah, so it's this one times this one gives you that one. So that's the probability of and a player is using performance-enhancing drugs and test positive. Okay? Everybody good? Yeah, multiplying across the tree. Now, what I do to make sure that I didn't make a mistake here is I always add these up, and they should add to 1. So take a moment right now, add those up, and make sure they add to 1. If they don't, then you've made a mistake somewhere. Right? So I got 1 when I added them together. Okay? Always good thing to do. Excellent. Well done. Okay, so number 1. Calculate the probability that a randomly selected player will test positive. Well, when I look at all 4 of these probabilities, check the box if they test positive. Does this one say positive?
Yes.
Yes? Does this one?
No.
This one?
Yes.
This one?
No.
So it's just these 2.
Yes.
So the probability of a player testing positive is 0.0495 plus 0.0285. Remember, I'm only adding it if it's got positive in it.
I agree. Watch the videos.
Well, I'm making this one for future classes. I realized when I was out that I didn't have a video of this, just a key. And it's helpful to have a video.
That's why we didn't watch the video.
There were other videos.
Oh.
Okay.
How many videos were there?
Any questions? I'm good. I've been parenting 4 children under the age of 6 for a week.
He's not a kid, though.
I understand, but sometimes even seniors act like children. Now, any questions on number 1?
1, 2, 3.
No. Great, thank you for answering. Appreciate you. Was there a question? No. Number 2. This is the hardest one. Okay. Number 2. If the player that we randomly select tests positive, what is that screaming at you before I even finish it? A conditional probability. That's what that's screaming at you. So the probability and the given is that they test positive. So we already know that the player we've chosen, whoever it is in the NFL, has tested positive. What's the likelihood that the player is actually using performance-enhancing drugs? Now, I'm going to show you, because it's not straightforward here. I'm going to show you the formula you're going to get on the formula sheet. Okay?
Was that you?
What? Wasn't me.
I'm the one asking.
It was me. Okay. Do you see this formula here?
Yes.
All right. The one on the formula sheet that I'm going to give you just changes the letters. So it's the probability of A given B, but it doesn't matter. You'll see it. The key thing is, whatever your given is, whatever your condition, that is the denominator. All right, so what was our condition in this problem?
Being positive, or testing positive.
Very good. So I'm going to put in my denominator the probability that the player is positive. And conveniently, we already answered that in the first question, right? So if you want to put that there, go. I'm going to in a second. Now let me go back to the formula. The numerator, do you remember what this symbol is? It's and. Very good, Diego. What up, man? It's and. So in the numerator, I'm going to put the probability that the player is using and they tested positive. Now, I like to think that this is straightforward. It might not be, because we're just talking about it for the first time. But what I learned this when I was in high school was my teacher said, well, if they told you they test positive and they told you we want to find out if they're using, then this in the numerator has to be and, because I want to know if they're using, but I already know that they're positive. So it has to be and of both of them. I'll try again. Let me try again. The numerator has to be the probability that they're doing this one and that one, because you already know this is happening. So if I want to know the likelihood that this is happening, it's these at the same time. That was better. That was better.
Just the one. This is just like that.
I don't know.
Just like the standardized.
It's just like the what? Standardized? No standardization. Okay, so this one, the numerator we have right here, using and positive. So 0.0495. And then you'll notice that number one was setting us up for success, because number one said, what's the likelihood the player tests positive, which is my denominator. So my number one is 0.078. So I want to just tell everyone listening to this video right now that most of the time when you do this on the AP exam, your denominator will involve some addition, right? It involved some addition to get that one. Okay? Even though it didn't look like I did any addition, I had already done it in the previous problem. So I just want to keep that in the back of your mind. Yeah, that makes sense? Okay, so divide these, and we'll have our answer. They'll just be this problem. Exactly. All right, so 0.635. Did I do it too fast, Jasmine? I'm sorry.
Yes, you did.
I'm sorry. Okay, so what is the likelihood that the player is using, all right, if I tell you that they tested positive? 63.5% chance of that happening. Okay? Which feels low, doesn't it?
That's high.
That feels high for you.
Just do what?
That feels low for me if I know that they test positive. What's the likelihood that they were using? That feels like that number should be higher.
That should be higher.
At least for me, I'd want to get a better test. Okay.